Well guys, today we're going to discuss about integrated circuit. Let's first examine the beginning. The first planar monolithic integrated circuit IC chip was demonstrated in 1960. The idea of integrating electronic circuits into a single device was born when the German physicist and engineer Werner Jacobi developed and patented the first known integrated transistor amplifier. In 1949, and the British radio engineer Geoffrey Dummer proposed to integrate a variety of standard electronic components in a monolithic semiconductor crystal in 1952. A year later, Harwick Johnson filed a patent for a prototype IC. Between 1953 and 1957, Sidney Darlington and Yasuo Tarui Electrotechnical Laboratory proposed similar chip designs where several transistors could share a common active area, but there was no electrical isolation to separate them from each other. These ideas could not be implemented by the industry until a breakthrough came in late 1958. Three people from three U.S. companies solved three fundamental problems that hindered the production of integrated circuits. Jack Kilby of Texas Instruments patented the principle of integration, created the first prototype ICs, and commercialized them. Kilby's invention was a hybrid integrated circuit, hybrid ICs, rather than a monolithic integrated circuit, monolithic ICs chip. Monolithic IC chip won between late 1958 and early 1959. Kurt Lehovic of Sprague electrically isolate components on a semiconductor crystal using pain junction isolation. The first monolithic IC chip was invented by Robert Noyce of Fairchild Semiconductor. 2-3, he invented a way to connect the IC components, aluminum metallization, and proposed an improved version of insulation based on the planar process technology developed by John Hoerni. On September 27, 1960, using the ideas of Noyce and Hoerni, a group of J-lasts at Fairchild Semiconductor created the first operational semiconductor IC. Texas Instruments, which held the patent for Kilby's invention, started a patent war, which was settled in 1966 by the agreement on cross-light. There is no consensus on who invented the IC. The American press of the 1960s named four people: Kilby, Lehovic, Noyce, and Hoerni. In the 1970s, the list was shortened to Kilby and Noyce. Kilby was awarded the 2000 Nobel Prize in Physics for his part in the invention of the integrated circuit. Or, in the 2000s, historians Leslie Berlin, Arjun-Saxena-Debo, Logipal Isagenders, and Arjun stated the idea of multiple IC gamethroers and revised the contribution of Kilby. Modern IC chips are based on Noyce's monolithic ICU-2-3 rather than Kilby's hybrid IC. Licensing. What is an integrated circuit? An integrated circuit IC is a tiny electronic device that contains many electronic components like transistors and resistors, all packed together on a single chip of semiconductor material, usually silicon. It's like having a mini electronic circuit on a small piece of silicon. Integrated circuits are the building blocks of modern electronics and are found in almost every electronic device we use, like smartphones, computers, TVs, and more. They make these devices work faster, consume less power, and be smaller in size. Think of an integrated circuit as a super efficient team of electronic components working together to perform specific tasks, such as processing information, amplifying signals, or doing calculations. Their small size and efficiency have revolutionized technology and made electronics more accessible and powerful. Well guys, today we're going to discuss about integrated circuit. Let's first examine the beginning. Types of integrated circuits: analog integrated circuits, digital integrated circuits, mixed signal integrated circuits, power management IC. Analog integrated circuits. These ICs deal with continuous signals and are used for tasks such as amplification, filtering, and voltage regulation. Examples include operational amplifiers, op amps, and voltage regulators. Digital integrated circuits. These ICs work with discrete signals or binary data, zeros and ones. They are the building blocks of digital electronics and are used for tasks like logic operations, data processing, and memory storage. Examples include microcontrollers, microprocessors, and digital signal processors. Mixed signal integrated circuits. As the name suggests, these ICs combine both analog and digital circuitry within the same chip. They're commonly used in applications where both analog and digital processing are required, such as data converters, analog to digital converters, and digital to analog converters, and communication systems. Power Management ICE. These ICs are specifically designed to handle power-related functions such as voltage regulation, power conversion, e.g. DC-DC, converters, and battery charging. Advanced disadvantages. Integrated circuits, XX, are small semiconductor chips that contain multiple electronic components, such as transistors, resistors, capacitors, and diodes, all integrated onto a single piece of silicon. They revolutionize the electronics industry and are found in virtually all modern electronic devices. Let's explore the advantages and disadvantages of integrated circuits. Advantages of integrated circuits. Size and weight. X pack numerous components onto a tiny silicon chip, significantly reducing the size and weight of electronic devices. This miniaturization allows for the development of smaller and more portable gadgets. Performance. ICs enable high-speed operation due to the short interconnection distances between components on the chip, leading to faster and more efficient electronic systems. Power efficiency. The integration of components on a single chip reduces power consumption since there is less energy wasted as heat in the interconnections. Reliability. With fewer external connections, there is a reduced risk of loose connections, corrosion, or short circuits, enhancing the overall reliability of the device. Cost effectiveness. Mass production of integrated circuits lowers the manufacturing cost per unit, making electronic devices more affordable to consumers. Versatility. ICs can be designed to perform various functions from simple tasks to complex computations, making them versatile and adaptable for different applications. High integration. The ability to integrate thousands to billions of components onto a single chip allows for complex systems and functionalities in a compact form. Disadvantages of integrated circuits. Complexity. Designing and fabricating integrated circuits can be complex and require specialized knowledge, equipment, and facilities, which can be costly. Testing and debugging. Identifying and fixing defects in integrated circuits can be challenging due to the miniaturized nature of the components. Sensitivity to SD. Integrated circuits are susceptible to damage from electrostatic discharge. ESD, requiring careful handling during manufacturing, assembly, and usage. Obsolescence. Rapid advancements in technology can quickly make older integrated circuits obsolete, necessitating constant updates and redesigns. Heat dissipation. High-performance ICs generate heat, and effective heat dissipation mechanisms are required to prevent overheating and damage to the chip. Intellectual property protection. Reverse engineering of integrated circuits is a concern, as it can lead to intellectual property theft and unauthorized duplication of designs. Environmental impact. The manufacturing of integrated circuits involves the use of hazardous chemicals, and their disposal can contribute to environmental pollution if not handled properly. Despite these disadvantages, the advantages of integrated circuits far outweigh the drawbacks, making them indispensable in modern electronics and computing. Researchers and engineers continue to develop innovative techniques to address the challenges associated with integrated circuit design and manufacturing. Thanks for watching the video.